Hello everyone, I hope you all are doing good. So in today's data structure tutorial, I'm going to talk on binary search tree, which is a node-based binary tree having below properties. Okay, so number one is the left subtree of a node contains only those nodes with keys lesser than the node key, right? And the second key property is the right subtree of a node contains only those nodes with keys or values, whatever you want to say, greater than the nodes key. Okay, so we can see that this is sorted, right? So the left is having the less value, the right is going to have the greater value. We mainly use it for indexing purpose. And if I have a shopping cart application, then I can make use of binary search tree to determine how many items I have purchased which are less than $100, right? So we make use of binary search tree in this kind of application. Let me give you an example. Okay, so what do I mean by the two properties? Here, my root node is having the key value is 100. Okay, and I can see the left subtree starting at is at 90. If I get a node which is 122, it is greater than 100, so it will be moved to the right side. Now, if I'm going to get an item which is 67, I'm going to check with 100. It is less, so I'll move to the left side. Again, I'm going to check with 90. It is less, so it will be placed at the left side of the 90. Fine. If I am going to have another item which is 1000, so I'm going to compare it with 2000. I'm going to compare it with the root node. So it is greater than 100. It is greater than 122 also. So it will be placed at the right side. Fine. Let's implement this in C++. Okay. So I'm going to use structure. So struct for defining the tree. So struct t node. So click, I'm going to put data, that is my key or value, whichever you would like to say, and then the left and the right pointers. So t node left and t node right. Fine. One more step, that is the initialization. So I'm going to put int x, and for every node that is I'm going to initialize data as x and left and right as null. Fine. The same activity we have done in the previous videos where we have discussed on tree data structure. All right, so we are good till here. Now I'm going to create the tree. So t node root going to give a value of 10. And now I'm going to define a function insert, which would be implementing binary search tree while inserting every node to this tree, which is having the root 10. Okay, so function t T node, insert, I'm going to pass two values. One is the node itself, sorry, and other is the value, which we would be using to check if it is greater or less than. So if my hroot is equal to null, then return new node with that value itself. Fine. Otherwise, this is the base condition for this recursive function. Otherwise, we are going to check if my data for hroot is less than d. We have to traverse to the right side. So d is the data for the new node. So if the new node is having the value which is greater than the value of the root node, we have to move to the right side. So hroot right and call the insert function again. Move to the right and d, the new data value that we want to insert. Otherwise, what we have to do, it is less than the root node value. So move to the left side. So hroot left, insert, all right. And after performing this, I'm going to return my hroot. Okay. So here let's insert the values. Insert. So root, I'm going to put 100. Then insert, I'm going to send the root of the tree and 22. Okay. After that, let's display. For display, I'm going to use the in-order traversal. So in tree data structure, we have discussed on three traversals, right? In-order, pre-order, and post-order. Here to display my tree for binary search tree, I'm going to use in-order traversal. Let's define the function. So tnode display going to pass the root, right? So now if this is null, return null. Fine. Otherwise, we have to do the in-order traversal, which is left, then that node itself, and then right. Okay. So I'm going to call recursively the function display for the left side. Fine. Going to display the root item itself, hroot data. Putting some space. And then the right subtree. So display hroot right. Fine. Okay. Now let's. Okay. So I'm going to put this function inside my structure definition. And let's call this function. So root display. And I'm going to send the root of the node. Fine. Let's run this program. Oh, we have an error. Okay, after the structure definition, I forgot to put the semicolon. Let's run the program and check the output. So 10 is my root node. After that, I'm putting 100 and then 22. So I can see the left in order traversal is the left 10, then 22 and 100. So let's modify here itself. Sorry. So I have 10 as my root node. Then I'm inserting 100. So 100 is greater than this. And then I'm putting 22. 22 is also greater than 10. And then I'm going to check with 100, but it is less than 100. So it is going to be at the left side. So here comes 22. And if we see the in order traversal, there's no left subtree of 10. So moving on to the right, then the left. And first, after left, we are going to print 10. Then we are going to print 22. Then we are going to print 100, right? I'm going to provide the GitHub link for binary search tree in the description section. Please check the code and perform for other tree structure. If you want me to touch on other part related to the tree traversal, please put in the comment section. I hope you like this video. Have a good day.